Have you ever pondered about what would happen if the Earth's magnetic poles were to shift? The Earth's magnetic poles are more than just guiding stars for our compasses. They are vital to life as we know it. But what if these poles decided to change places? What would be the impact on our planet and its inhabitants? These are intriguing questions that capture the imagination. In today's video, we will delve into the fascinating world of Earth's magnetic poles and their potential shift. So, what exactly are the Earth's magnetic poles? Well, they're not as mysterious as they might seem. In fact, they're a crucial part of our planet's inner workings, and understanding them can unlock a lot of knowledge about our world. Let's start with the basics. The Earth's magnetic poles are the 2 points where the planet's magnetic field lines converge. You can think of them as the north and south ends of a giant magnet, with the north magnetic pole in the Arctic and the south magnetic pole in Antarctica. But what creates these magnetic poles? It all comes down to the Earth's core. Our planet's core is made up of iron and nickel, and it's separated into 2 parts, the solid inner core and the liquid outer core. The outer core is constantly in motion due to the Earth's rotation, and this movement generates electric currents. These currents, in turn, produce the Earth's magnetic field. This magnetic field is crucial for life on Earth. It extends thousands of miles into space, forming a protective barrier that shields the planet from harmful solar radiation. Without it, the solar wind, a stream of charged particles from the sun, could strip away the Earth's atmosphere, leaving the planet barren and lifeless. The Earth's magnetic poles aren't fixed points, though. They tend to wander, and over long geological timescales, they can even switch places in an event known as a geomagnetic reversal. This is a normal part of Earth's geologic history, and it's occurred hundreds of times over the planet's 4.5 billion-year lifespan. Now that we have a basic understanding of what the Earth's magnetic poles are, let's explore what it means for them to shift. This is a fascinating topic that delves into the heart of our planet's geology and its magnetic personality. So, stay tuned as we delve deeper into the movement and effects of Earth's magnetic poles. The shift of Earth's magnetic poles is a phenomenon that has intrigued scientists for decades. Now let's delve into what exactly this shift means. Essentially, the Earth's magnetic poles aren't fixed. They wander, influenced by the movement of molten iron within the Earth's outer core. This movement generates an electric current, which in turn creates our planet's magnetic field. Picture it as a colossal bar magnet running through the center of the Earth, with its poles near the geographic north and south poles. But here's the catch. Every few 100,000 years or so, the polarity of this magnet flips. This is what we call a geomagnetic reversal. Now you might be wondering, has this happened before? The answer is yes, quite a few times actually. The last reversal, known as the Brunhes-Matuyama reversal, occurred approximately 780,000 years ago. But don't worry, these reversals are far from instantaneous. They are slow and gradual processes that take thousands of years to complete. So how do we know all this? The evidence lies in the rocks. When lava cools and solidifies into rock, tiny magnetic minerals within the lava align themselves with the Earth's magnetic field. This alignment gets locked in as the rock solidifies, providing a permanent record of the Earth's magnetic field at that particular point in time. By studying these rocks, scientists have been able to map out the history of our planet's magnetic field. But here's where things get a little more intriguing. The Earth's magnetic field isn't just flipping, it's also weakening. Over the last 170 years, the strength of the magnetic field has decreased by around 9%. While we're not entirely sure why this is happening, some scientists believe it could be a sign that we're heading towards another geomagnetic reversal. The shifting of Earth's magnetic poles is a slow and gradual process, but what could potentially happen if such a shift were to occur? Let's explore this question in the next scene. The potential significant movement of Earth's magnetic poles over time, also referred to as geomagnetic reversal, has vast implications for life on Earth. To comprehensively understand these implications, let's delve deeper into the Earth's magnetic field. This colossal cosmic shield safeguards our planet from harmful solar radiation. A slight shift in the poles, even momentarily, might cause this field to weaken, resulting in an increase in radiation exposure. This could lead to numerous health issues, including skin cancer, and even affect our planet's climate. Further, let's examine the vulnerabilities of our navigation systems and electric grid. In today's technological era, various systems significantly rely on the Earth's field, such as the electric power grid. A change in the Earth's magnetic field can induce currents in these systems, which could potentially overload and cause widespread power outages. The same goes for satellites and communication devices. Disturbances in the Earth's magnetic field could lead to satellite hardware failures and interruptions in telecommunications, which could have serious implications on our daily lives. The Earth's magnetic field also plays a crucial role in GPS technology, used in everything from your smartphone to ships and airplanes. If the poles flip, these GPS systems might face significant inaccuracies, requiring recalibration or even total revamping to operate correctly, posing an immense challenge in a tech-dependent world. It's not just humans that would be affected. Numerous wildlife species, including birds and sea turtles, depend on the Earth's magnetic field for navigation. A pole shift could and potentially disrupt migration patterns and ecosystems. But there's no need for immediate panic. Although these potential consequences could be severe, we should understand the broader picture. The Earth's magnetic poles have shifted multiple times throughout history, and life has continued to thrive. It's important to remember that a pole shift is not an immediate event. It's a process taking thousands of years, providing life on Earth enough time to adapt and adjust. In summary, while the significant movement of the Earth's magnetic poles carries considerable implications for our planet and its inhabitants, including vulnerabilities in electric grid, satellite, and communication systems, it's a slow process that life has successfully navigated throughout history. Although the shifting of Earth's magnetic poles can have severe impacts, it's a process that takes thousands of years, providing time for adaptation and technological advancements. Now that we've explored the broader aspects of Earth's magnetic poles and their potential shift, let's dive a bit deeper into the technicalities of this phenomenon. The Earth's magnetic field is not a simple static feature, but a dynamic, ever-changing force. This force is generated by what we call the geodynamo, a process driven by the convection of molten iron within the Earth's outer core. As this molten iron moves, it creates electric currents, which in turn generate the magnetic field that envelops our planet. During a geomagnetic reversal, this magnetic field weakens, possibly to about 10% of its normal strength. During this time, the field becomes more complex and might show more than two poles for a short period, before the poles flip. This is not a quick process, but a gradual change that occurs over thousands of years. The last known geomagnetic reversal, known as the Brunhes-Matuyama reversal, occurred approximately 780,000 years ago. So, in geological terms, we might be due for another one. But remember, this is not something that happens overnight, or even within a human lifetime. While the technical aspects of Earth's magnetic poles and their potential shift can be complex, understanding them can help us better appreciate the dynamic nature of our planet. It also reminds us that while we live our lives on a day-to-day basis, Earth has its own timeline, operating on a scale that stretches back billions of years and will continue for billions more. Thanks for staying tuned. Please like and subscribe InfoVibe for amazing content.